Hello, everyone. I want to talk about predicting products of chemical reactions. And in order to do that at this level, what I'd like to do is talk about the 5 different reaction types. So their reactions can be broken down to actually 5 types. This is actually more like 3, but more on that later, okay? Anyway, you'll see 2 types of reactions right here. Again, there's 5 of them, 5 reaction types. And then what you see on the board here is what's called a synthesis reaction. Synthesis means to make. And synthesis reactions are most notable because you take a couple things, 2 or 3 things, and you create one product. Okay? So you create one product. Typically, these things are going to combine. You're going to see something like, another example is Na plus Cl2 yields NaCl. Now, I have not balanced it, but notice a couple things produce one product. H2 plus O2 yields H2O, one product. Okay? It could work in several different ways, but we're going to keep this pretty simple. So a synthesis reaction creates one product. A decomposition reaction, the next reaction type, breaks that single product down. So now you'll have a single, I said product, excuse me, you'll have a single reactant now. So it's the mirror image of a synthesis reaction. So synthesis reactions have a single product. Decomposition reactions means to break down, you have a single reactant, and it'll break down to its parts. I'm going to leave these pretty simple, okay? What you're going to see is something like like a binary compound. Binary means 2 things. That'll break down to its parts. Don't forget Professor H. Brauncliffe, that's why it's Cl2, okay? Another example of this, AlCl3 breaks down to Al, which is not Professor H. Brauncliffe, plus Cl2, Professor H. Brauncliffe. And then you have to go back and balance that. It's actually 3, 2, 2, okay? 2, 2, 3. Some more chemical reactions, 2 that actually go together, are called single replacement reactions and double replacement reactions. Single replacement reactions involve a single compound, a single element plus a compound, okay? You'll notice that these things just switch places. The Na was alone, and the CO was with the O. Now the Na is with the O, and the Cu is alone, okay? You'll notice double replacement reactions do the same thing. They just replace the cation. So the cations switch places, okay? So between single replacement and double replacement, the cations just switch. Notice NH4 is a cation. It's kind of a complex cation, but it's still a cation nonetheless. Ca is a cation. They switch places. So where the NH4 was with the Cl, over here it's with the OH. They just switch places. The Ca was with the hydroxide, but now it's going to go over with the Cl minus and create CaCl2. Okay? A little bit more simple way to look at this one. Take sodium chloride plus magnesium oxide. Okay? Switch the cations. The magnesium's now with the chloride. When you look up the ion sheets, it looks like this. And the sodium's with the oxide. It's now Na2O. And then you'd have to go back through and balance it. So you see, I'm just switching places. Okay? Very easy to understand that. Okay? The next one, oh, by the way, with this one, let me go back to this. Notice a single replacement involves a single element plus a compound. The pattern for double replacement is compound plus compound. And anytime you see compound plus compound, you need to be recognizing that that is a double replacement reaction. The last type of reaction is called combustion. Something is going to burn in the presence of oxygen to always produce CO2 and H2O, okay? Actually, I'll take that back. It's not always CO2 and H2O, but it's pretty close. So if I have, let me say it this way, if you have a hydrocarbon or an alcohol, or actually we'll stick with that, hydrocarbon and alcohol. This is a hydrocarbon, and you react that with oxygen. Oxygen always has to be here. Oxygen always has to be here. No big deal about that. You'll get CO2 and H2O. Okay, that's combustion. That pattern is pretty standard. So trying a couple of these, let's just see what we can do here. Let's predict the products of these reactions. So if I have lithium metal, reacts with fluorine gas, don't forget, it's just not F, it's Professor H. Brauncliffe. There's an F in there. To produce, well, Li is plus, F is minus. Now where are these things coming from? Remember, Li is a metal, lithium's a metal. So we use our ion sheets. Remember, it always goes back to the ion sheets. LiF. And of course, we should balance this. In order to do that, you need a 2 here because of the 2 and a 2 here. Okay, 2, 1, 2. Okay, I'll do sodium peroxide in class. Let's go to this one. An aluminum sheet, that's just aluminum metal, reacts with oxygen here. Professor H. Broncliffe, be careful, that keeps popping up, guys. So Al is 3 plus, because that's a metal, so I use my ion sheets. O2 minus, I need Al2O3. And to balance this is correct. Okay? Again, if you ever need to pause the video and do things before I get to them, or you want to challenge yourself, you need to do that. Okay? We will practice more of these in class. Actually, let me give you one more. Okay? If I have perhaps magnesium sulfate, and I've written that correctly because this is plus 2, this is minus 2, plus, I'll keep it nice and simple, NaF. Again, you're going to recognize that this is a double replacement reaction. Okay? With the double replacement reaction, you switch the cations. I have compound here and a compound plus here, so you just switch the cations. But now every time you switch ions, you got to think of the ion sheets. So Na is going to be with the sulfate. Na is plus 1, but sulfate's 2 minus. So your answer is Na2, well, I'll write it right here, Na2SO4. It's an S. And the magnesium's now with the fluoride. Okay, so the magnesium's now with the fluoride. Magnesium's 2 plus, and whoopsie, fluoride is 1 minus, so I need to double up those. So it's MgF2. Done. And of course, you'd have to go back and balance that, and I think that does it. Okay? So again, actually, let me go back one slide. How do I know what to do here? I have element plus element to produce one product. That is a synthesis reaction. Sodium peroxide breaks down. That's going to be Na2O2. Breaks down. Single reactant, that is a decomposition reaction. So I follow the rules or the steps or the patterns of decomposition reaction. Aluminum metal is singular. Plus oxygen, singular. This is another synthesis reaction. Okay? So again, we're following the steps. I'm going to do one more. I just decided it right now. So let's add a slide here. See if you could do this one all by your lonesome. Let's see if I have, let me go with this one. Aluminum nitrate plus calcium metal. Calcium, that's Ca. Okay? So pause if you need to. First of all, recognize what kind of reaction is this? Well, you have, it does, I know they're out of order, but you have a single element plus a compound. That's a single replacement reaction, So this is going to switch with this. So the calcium was alone, now calcium will be with the nitrate. Writing that correctly is CaNO3 and now the aluminum, which was nitrate, is now alone. Okay, and to balance that, you need a 2, 3, 3, 2. That's correct. Okay? All right, if you have questions, let me know. Email me. We'll go over this in class a little bit more. Definitely a little bit more.